Each of 6 segments in the diagram below is painted randomly, either red or blue. And the question asks, what's the probability that there will be either a red square or a red triangle painted in the diagram? Okay. So we're looking for probability. So probability is the number of desired outcomes over the total number of outcomes. Okay. And the total number of outcomes for this diagram, we have 2 choices for every segment, right? And we have 6 segments. So the total number of ways that we can paint this diagram is 2 to the 6th. All right? And 2 to the 6th is just 4 times 4 times 4, which is equal to 16 times 4, which is 64. All right? So that's the total number of ways that we can paint this diagram. So that'll be the denominator of our probability. And the other thing we need to figure out is our desired outcomes, and in this case our desired outcomes are either a red square or a red triangle, or both painted in the diagram. Okay. So if first of all, let me pick up a red pen, let me draw. So we have a case of a red triangle, and then we have 3 other sides. Or we have a red square and 3 other sides painted randomly, or sorry, 2 other sides painted randomly. Okay. So you might think that, okay, so we have 3 segments here. We have 2 choices for each segment, so that's 2 to the 3rd, which is 8 different ways that we could paint it with a red triangle. Okay. And in the case of the red square, we have 2 other segments, and we have 2 ways to paint each one of those segments. So you might think, okay, 2 squared is 4. All right, so we have 4 ways to paint these. We have 4 ways to paint the diagram such that we have a red square on the bottom. Okay, but we have to be a little bit careful. All right, because let's see if we can draw out those 4 ways. Are these? Well, let's first of all start with the red triangle on top. So we have 8 ways to draw these. So I'm going to draw just a bunch of red triangles because they're all going to have red triangle on top. Okay. And, okay, let's see if we can draw all these scenarios. I'm going to make all of my first 4, I'm going to make them all have a red left side. Okay. And then, so let's see. And then let's make the bottom ones, let's say they'll have a blue left side. Okay. And, alright, so let's go ahead and finish drawing these. Where'd my pen go? Oh, there we go. Alright, so, let's see, we could have a red, blue, blue. We could have a red, we could have the other blue be on the side, we could have the other red be on the bottom. Or we can have all red, right? So this would be red, and this would be red. Okay, so let's look at the these other ones. We could have a blue and a red red. We could have the other red be on the side. We could have the other red be on the bottom. And let me go back to blue. So let's fill in the rest with blue, blue. And it looks like we could have blue, blue, right? Is that all the scenarios? I think all those are unique. So those are our 8 scenarios where we get a red triangle on the top. Okay, so now let's look at the blue square. Now we said we would expect to have 4 cases here. So let's draw them. So okay, so let's draw 2 of them with a red left side. And so then, let's see, we could have, again I lost my pen, there we go. We could have a blue, we could have a blue, blue, we have a blue, and then it looks like, let's see, I think this one would have to be red, and this would have to be red to get all different ones, right? Okay, so I've got red, blue, red, red, blue, blue, and blue, red. Alright, so there's our 4 ways. Alright, so, but we have to be careful because, let's take a look here. We have 2 of them counted twice, right? We have this red square with a red triangle on top, and we have a red triangle with a red square on top. So we want to have to be careful there because that's really just one way to paint it, okay? So, so instead of 8 plus 4, which is 12, we actually have 8 plus 4 minus 1, which is 11 ways to paint the diagram so that we get either a red square or a red triangle painted in the diagram. So our probability then is 11 out of 64.